Hello everyone, my name is Jaina Reddy and I'm a CSC Data Science student at IRE Hyderabad. In this video, I'm going to tell you about system protection. So, outline of this presentation is system protection definition, need for the protection, and elements of the protection system. So, what is a protection system? System protection is an art and science of detecting problems with power system components and isolating these components. Power system protection is a branch of electrical power engineering that deals with the protection of electrical power systems from faults through the disconnection of faulted parts from the rest of the electrical network. The objective of a protection scheme is to keep the power system stable by isolating only the components that are under fault, list leaving the as much of the network as possible still in operation. The devices that are used to protect the power systems from faults are called protection devices. So, need for the protection are the power system must maintain acceptable operation 24 hours a day. Voltage and frequency must stay within certain limits. Protect the public. Improve system stability. Minimize damage to equipment and protection against overloads. So, damage to main equipment. So, it may be severe cause if main the hard disk if they are failed and the servers may blast like this. So components used for protection are current transformers, voltage transformers, protective relays, circuit breakers. And components to be protected are generators, transformers, lines, buses, and capacitors. So generator protection. What can go wrong? Stator winding problems that are winding short. So how do we protect the stator? Differential protection. It takes phase faults. By coming to transformer protection, what can go wrong? Winding to winding faults, winding to ground faults, and bushing faults. And protection methods are fuse, overcurrent, and differential. Transmission line protection. So in this, what can go wrong? Faults that are circuits and stress, light, trees, lightning, animals like birds, squirrel, etc., and weather of wind and snow, natural disasters like earthquakes, floods, tsunami, and faulty equipments like switches, insulators. So, types of faults: single phase ground, that is 70 to 80%, and phase ground, that is 17 to 10%, and phase fault, that is 10 to 8%, and three phase fault, that is 3 to 2%. How do we protect the transmission lines? By overcurrent and bidirectional overcurrent, distance, that is impedance, and line current differential. So here is the power supply. Here is a current transformer that is passing through the line circuit breaker, and we have the power supply from here. So this is a directional overcurrent relay of from power supply to line circuit breaker and power supply to current transformer and power supply to current transformer to CVT. So what is distance protection? A distance relay measures the impedance of a line using the voltage applied to the relay and current applied to the relay. When a fault occurs on a line, the current rises significantly and the voltage collapses significantly. The distance relay, also known as the impedance relay, determines the impedance by Z equals to V by I. If the impedance is within the reach setting of the relay, it will operate. So here is the current passing through the relay and to the resistance and the circuit, and here is the fault. So we can take the consider the formula Z equals to V by I. So V equals to voltage and I is the current. And here is the bus bar, basic connection diagram of protection relay. And to the bus bar, it's connected to CB, and CB consists of tip coil. And here is the relay, which consists of tip contact. So here is the basic connection. So how the current passes and how it is protected inside the system. So here is a bus protection, means bus differential current into bus must equal current out of bus. So her current into the bus is from here, and the voltage is passing through the relay and relay to the CB and to CT, and here to the bus bar. Though we can connect directly to CB to this bus bar, it may be easy, but here if we connect the to relay, we may cause less damage or no damage. Capacitor protection. Purpose of capacitors. Shunt capacitor raises the voltage on a bus or line to a higher level, thus helping the voltage keep the voltage at desired level. Series capacitors cancel out the inductive reactance of a line, thus making the line appear shorter, increasing load flow of the line. So here is a diagram of it, and here is the bus bars, and through bus bars there is an isolator, and from the isolator there is a breaker. From the breaker there is overcurrent protection, which protects the overcurrent flow. It maintains the equal flow between the transmission lines. And here is a capacitor bank, which shows which collects the exact amount of current and passes through the voltage, and over voltage and time delay relays are fixed here, and the outlet is neutral PT. Thank you.